So number 15, the monthly water bill is a function of the number of gallons used. The cost is $19.50 for 20,000 gallons or less, and then over 20,000 gallons, the cost is $19.50 plus $1 for each 1,000 gallons over 20,000 with any fraction of 1,000 gallons charged at a fraction of $1. So it sounds like a lot. What we need is this piece here, and then that's kind of the next part of the important part. And then on what interval is the cost constant? On what interval is the cost increasing? So let's look at constant first. So we want to know when this is constant. What they're asking is, when are we always charged the same amount? All right, here highlighted in green, it says the cost is $19.50 for 20,000 gallons or less. All right, so it's constant from 0 all the way up to 20,000 gallons. So how do we write that mathematically? Well, we can use interval notation. All right, and no matter how much water we use up to 20 gallons, it's always going to be the same. So it's, again, a constant charge. So in interval notation, my minimum amount would be 0. Now, I could use 0 gallons of water and it'd still be charged because that's going to be my bill. And then that's going to go up to 20,000 gallons. So at that 20,000 gallons, that can still happen 20,000 gallons or less. So I'm going to put a bracket there. The second part of this is they want to know on what interval is the cost increasing. So when is it increasing? Now, we don't really care about the actual function in the formula here. They just want to know on what interval. So in yellow, it says over 20,000 gallons, the cost is $19.50 plus $1. So there's a whole formula to figure out what the cost would be, but it's increasing when it's over 20,000 gallons. So again, in interval notation, how do we state that? Now, there's really no limit here. It's just anything over 20,000. There's no cap on how much water we can spend. I mean, in reality, there's going to be a limit to how much water you can actually go through. But for the sake of this problem, what we're looking at is the minimum and the maximum value. So that minimum in interval notation would be 20,000. All right, at 20,000, our graph is going to start increasing, or our charge is going to start increasing. And that's going to increase to infinity. All right, there's no limit to how much water we can spend. Again, realistically, yes, there will be something, but for the sake of this problem, there's nothing. So we're going to put a parenthesis there. If this was a graph, your cost would look something like this. It would be flat for 20,000, and then it would start going up when you hit that 20,000 mark. Too many zeros there. So 20,000, it would start increasing. Let's take a look at number 22. The concrete company charges $160 for delivering less than 2 yards of concrete. All right, so $160 for less than 2 yards of concrete. Now, for 2 yards and more, the charge is $80 per yard, again with a fraction of a yard charged as a fraction of $80. Won't worry too much about that, but use function notation to write the charge as a function of the number x of cubic yards delivered, where 0 is less than x, which is less than or equal to 10. So we're not going to order more than 10 cubic yards, and then we're going to be asked to graph this function. So let's call this, let's say f of x. We're going to look for a function f of x, and then we're going to come up with some kind of piecewise function here. So the first part of this is that we're charged $160 for delivering less than 2 yards cubed of concrete. So no matter what, it's $160 for anything from 0 to 2 yards. Let's fix that because it says less than 2 yards. So let's get rid of that. So it's going to be greater than 0. We're not going to be charged if we don't get any concrete. So it's not going to be equal to 0, and it's less than 2 yards, not equal to 2 yards. So 0 is less than x, which would be less than 2. Now, what happens when we go above 2? For 2 yards or more, so our minimum in this case is going to be 2, and it could be equal to that. The charge is $80 per yard with a fraction of a yard charged as a fraction of $80. So we're charged $80 per yard cubed. All right, and we're going to use X as our yard cube. So if you were to get 3 yards cubed, it would be 3 times 80. If you got 5 yards, it would be 5 times 80. And when this is going to go from is from 2, it can be equal to it. So for 2 yards and more, so 2 is less than or equal to X, which is going to be, what's our cap here? Well, they're telling us this is our price up to 10 yards. All right, so we've capped at less than or equal to 10. Now we're going to be asked to graph this function. I'm going to draw a pretty rough sketch, but we just want to get the idea of what this might look like. I'm going to go up by 40s here. So 40, 80, 120, 160, 200. That's enough, we get the idea. And then the most we can go up to is 10. So let's just cap that at 10. And then 2 is going to make a difference here. So from 0 to 2 yards, what's going to happen is that we're going to be charged $160. So no matter what, it's going to be $160 from 0 to 2. Now, again, we can't be charged for not buying anything. So at 0, it's going to be an open circle. At 2, if we ended there, it would be a closed circle, an open circle. But it's going to start going up by $80 per yard. So it's going to increase. That's not going to be perfect, but you get the idea. And this is eventually going to end at that 10, and we would have a closed circle at 10. Okay, that's where it would stop because, again, this only goes from 0 to 10 yards cubed. So graphing this, you're going to have a flat part. Sorry. This would be the increasing part over 2 yards, and this piece here would be from 0 to 2 yards. One more time, 0 being an open circle because they can't charge us for not buying concrete.